Okay, so if you got a vector representing 20 meters per second at 30 degrees with the x direction, I ask you to write down Vx and Vy, right? What's Vx? Automatically, it is 20 meters per second times the cosine of 30 degrees times the I vector. And the Vy is 20 meters per second times the sine of 30 degrees times the J vector. So if you haven't written this down and you're already thumb punching your calculator, you're doing the wrong thing, right? I don't care if you go ahead and thumb punch your calculator here, although if you do it on this one, I will hassle you a bit, okay? Because you need to know the sine and cosine of special angles, right? 30 degrees, 60 degrees, 45 degrees, and the angles in other quadrants that make those same angles with the x-axis. Okay, anyhow, so dx is 20 meters per second times what? Square root of 3 over 2 I, and Vy is 20 meters per second times 1/2 J. There they are, okay? In the square root of 3 over 2, everybody knows the square root of 3 is 1.732, so that's like 0.866, right? How can people get through life not knowing the square root of 2 and the square root of 3? I mean, it's ridiculous. The only people who didn't know those things when they put the men on the moon were people with IQs under 14. Well, I'm exaggerating. Or people who weren't paying attention, or people who just had no ability to remember numbers, okay? But any college transfer student at that time knew these things. Now it becomes less necessary, but those are two frequently used numbers. You see that they get used here, right? The square root of 2 over 2, you know, you got that one too. That's why those numbers are important. The square roots of numbers from, 1 through 4. Okay? Helps to know some of the others, but those are kind of essential for understanding a lot of things. Okay. Well, anyhow, that comes out to be about 17. I'm just going to say about 17 meters per second times I. You want to go a little further, 17.32, because that is 10 times the square root of 3 or 20 times the square root. Okay, and this one, most of you know that 20 times 1/2 is 10, so that one's really easy. Okay? Now, if you don't know the circular model tells you unit circle. Here's if this is theta, then this is a cosine of theta, and this coordinate here is a sine of theta. We'll use this again and again. If you don't understand this, email me saying, gee, man, I didn't get that in my pre-calculus or trig course or whatever. Can you give me a link? I'll give you links to my stuff, and I'll tell you go look at the same thing on Khan Academy or wherever, okay? Because this is a picture that we're going to use uniformly. I'm not going to say much about triangles, although they're kind of important for visualization. I mean, they really are important, okay? But I'm going to kind of confine to this picture because it keeps everything very simple. Okay? Now, if you have had statics and you're really used to thinking in terms of triangles, maybe you won't think it's as simple as it is. I can't help it. if you've been corrupted by engineering thinking. No, I'm just kidding about that, obviously. Okay? We want engineers to be able to build things, right? We want them to work, so I have nothing against engineers or engineering education. Okay? We're trying to complement it a little bit here. C-O-M-P-L-E-M-E-N-T, not C-O-M-P-L-I-M-E-N-T, in case anybody knows the difference in the last 20 years. Okay? I could complement it too. I could complement it and complement it. Both spellings. Even though I make fun of it sometimes. Okay. I'm just trying to stretch your imaginations a little bit. Live with it. Okay.